In this lesson, we're going to be talking about functions and relations. So all of this should be content that you've learned before and we're reviewing. So we're also going to talk about function notation and domain and range. So a function and a relation talk about inputs and outputs as they relate to each other. So if you think about those ordered pairs of all of those points on a graph, that is your input and your output. The difference between a function and a relation is that a function only has one output for every input. So back in middle school, when you first started learning about functions and function notation, you would have talked about the vertical line test. So if you have a graph and you take your pencil left to right across the page, you only touch one point, then we can say that something is a function. There are 4 different ways that we can represent relations and functions. The first way is just a list of ordered pairs. Again, x and y, those points on the graph, inputs and outputs. We can take those x and y values and make a table of values. So your x values would go into the first column. F of x is your notation for a function. So remember that is your y value. We can have a mapping diagram. So a mapping diagram puts all of your inputs or x values in one oval together. All of the outputs go in the second oval together, or it could be a box. It doesn't matter the shape. And then we have arrows that connect inputs and outputs. So for that particular point, that particular relation, it would have points at 0, -2, 0, 1, because there's lines connecting those points. 1 has an output of 2, 2 has an output of 1, and 3 has an output of 4. And then we can also take and graph those points on a plane. If it was a function, we would connect the points to show that there's all those infinite values in between. This is a discrete graph, meaning that those dots are not connected, so we have independent values. So again, order pairs, tables, mapping diagrams, and graphs. The other thing that you've talked about related to functions are domain and range. Domain is the set of inputs or x coordinates for the relation. Range is the set of outputs or all of the y coordinates. So as we think about all of these parent functions and all of these different types of graphs that we've looked at, sometimes I can't put a certain x value in. So like for square root functions, we don't take the square root of negatives and we're talking about the real number system. So that limits the domain. A quadratic function is a parabola, so it's going to reach the top highest point, and the range would be everything below that. If you have a discrete value, meaning that they've just listed out the ordered pairs for you, and you're asked to find the domain and the range, to find the domain, we would just list out all of the x values from those ordered pairs. So -3, 0, 2, 9, and 23. And then the range would be the same, the list of the y values, 14, 7, 0, -18, and -99. And as you see, they use the swirly brackets, so that's how we note that we're talking about a list or a set of numbers. We would have to specify and like write out the word domain, write out the word range, just as I've done here on this slide, so that people know what we're talking about. We list them and use commas in between the numbers. We're going to practice a lot with domain and range on some graphs in just a second. Function notation. Function rule is an equation that represents an output value in terms of an input. So all we're thinking about is if I have some equation, some expression, I put in x, I put a number in for x, and calculate the output to get some number, we're using function notation. So again, we talked about this f of x. X is the input value. Once I calculate that 3x plus 1, that is the output. That's what creates the ordered pair that is the graph. It's the function. We're going to take the input for x, so the value inside of the parentheses, and it's going to take place of every single x value. In this case, there's only one. If there was more than one, we would replace for all of those. And so then we're just going to calculate. So 3 times -3 is -9, and we're going to add 1. So our final answer is 8. So on this graph, we should have a point at -3, -8. To evaluate for f of 1, again, we're just going to take and plug in 1 in place of all of the x values. 3 times 1 is 3. 3 plus 1 is 4. And then f of 7, the last one, 3 times 7, and then add 1. So 3 times 7 is 21. 21 plus 1 is 22. Domain and range, we have a couple different notations that we want to use for domain and range, again, when we're talking about the x values. So for algebraic notation, we're going to think inequalities and equality signs. So things like that would be less than, greater than, less than or equal to, greater than or equal to, or it might even just be not equal to. So for example, if we had a parabola and let's say that it hits a high point, if it's facing that direction, and then maybe our vertex was at, we'll say 4, 7. If we're going to talk about the range, we're going to focus on the 7 because that's the high point. So we would say that all of the y values are going to be less than or equal to 7. And then for this function, the domain is all real numbers. And so we can say that all real numbers, it kind of looks like that fancy R with 2 lines through it. For interval notation, that uses parentheses and brackets. So parentheses means that we have an excluded value. We might go right up against that number on the graph but never actually touch it. And then brackets mean that we are going to include those numbers in the domain and range. And so we would read the graph. If we're talking about domain, we read the graph left to right. If we're talking about the range, we're looking and reading the graph top to bottom. So we would read left to right for domain or top to bottom for range. So we would put either parentheses or bracket. We might have a starting value at 7. But because I'm using parentheses, I'm not actually including it. And then it might go to positive infinity. So infinity signs are going to also use the parentheses. I know that can be a little confusing, so we're actually going to work some examples together where we look at some graphs. All right, continuous functions. A continuous function means I can trace that image without picking my pen or pencil up off of the paper. So we're going to have range or intervals of x and y values. So for the domain of this first graph, it kind of looks like an upside down V. Again, we're thinking about left to right, where is the graph starting and stopping? And we have part of the graph in between those 2 purple lines from -2 all the way to 4. So again, I read the graph left to right. It started at -2 and it went to 4. So I list those 2 numbers with a comma in the middle. And then we have to pay attention to the endpoint. So if this is a solid point, then we're including that value. So if you remember back to doing inequalities and number lines way back in elementary school, you used an open circle if it was not included. So this one we're including -2, and we're also including 4, and we know that because we're using closed circles on the graph. For the range, again, we said we're going to go from the bottom of the graph up to the top, and you want to look for the highest point that you can find. So we're starting at the bottom at -3. Again, that's a closed point, so we would use a bracket to say that we're including that value, comma. 4 on the y-axis is the highest point, and again, it's a closed circle, and so we would use a bracket. If you struggle with domain and range, when you have a graph, I would really encourage you to use this idea of kind of blocking off on the graph where you see those points. That will help you see where the graph is starting and stopping. And again, if it has arrows, that means it's going on forever, so we'd be using infinity. For this one, we're going from -2, that's a closed circle there, so we're going to use brackets, over to 7, another closed circle, so we would include a bracket. And then let's look at range. So the lowest point on the graph is down on this side. Highest point is going to be at 6. So bottom of the graph, -3, up to the top of the graph, which is 6. Both of those are closed circles, and so we would use brackets. I didn't mean to erase all of that. There you go. Again, if those were open circles, we would have used some parentheses there. So for the next two graphs, domain, left to right. Again, now what's different on this first graph is that we do have an open circle over here at 4. So we're starting left side of the graph at -2, right side of the graph at 4. So I can start just by writing the beginning and ending point there. The -2 is going to be a bracket because we're including it, but because the 4 has that open circle, it's not included, and so we would use parentheses to show that we're going all the way up to 4, but not actually reaching 4. And then same thing for the range. Bottom of the graph is going to be down here at -3. Highest point on that graph is at 3, but it's still on that open circle, which means that we would use parentheses for the 3, and because the point at the -3 is darkened, then we'll use a bracket. So the next one is one of our parent functions. So this is our square root function, and we kind of mentioned earlier that we can't put negative numbers into a square root function, or just for the parent function. So we see that the domain of the graph, we're starting at 0, and it's a closed circle, so it's included. However, we have an arrow, which means that this graph doesn't stop on this side. So we're going to use the infinity symbol, and because infinity doesn't have a value, we use parentheses to talk about that number in our interval notation. So then for the range, the bottom of the graph still is here at the origin at 0, 0. So we're starting at 0. Again, we have this arrow, so I can't draw a second line for where this graph is going to stop. It's going to continue to go to infinity. So we again use infinity symbol with parentheses and a bracket to note that we're starting at 0 on the range. All right, couple more graphs. So we have another couple of our parent functions here. So we have an absolute value function that's been moved around and transformed. So again, we're going to go back and talk about transformations of functions in the next couple of days. This graph has arrows on both the left and the right side, which means I can't use those dotted lines to close in that graph. So we would say that this graph is going from -infinity to +infinity. And then we also could write this as all real numbers. So if you haven't seen that notation before, that's just another way to say all real numbers. For the range of the graph, the bottom of the graph is at this V shape down here, which is at -3. that is included, so we're going to use a bracket. However, the tops of those graphs are going up to positive infinity, so we can't close that in. Our last graph here is a cubic function. So again, we read the graph left to right. We have this closed circle over here on the left side, and then we have an open circle on the right side. So we're limiting our domain for this function to be from -5 over to 6. The -5 has a closed-in circle. We're going to use a bracket. 6 has an open circle. We're going to use parentheses. And then for the range, we're not looking at the same endpoints. This is where we can get tricked a little bit. We want to be careful. This graph, it's not on that specific point, but the graph is going to go all the way down to kind of that S curve, and then the same thing at the top. It's going to reach up to the top of that graph. So this graph is going to stretch from -6 up until 2. Both of those would be included points on the graph because there's no open circles there.